How to intuitively understand minus T delta S for Helmholtz free energy. Imagine you're watching a ball roll down a hill. It moves naturally because the system prefers a state of lower energy. Now, think of the system in terms of energy and disorder. That's where Helmholtz free energy comes in. It helps us see which states are more likely to happen naturally. Helmholtz free energy is defined as the internal energy of a system minus the temperature times the entropy. The term minus T delta S is about how the disorder or randomness in a system influences its energy. When entropy increases, meaning the system gets more disorganized, the value of minus T delta S becomes more negative. This negative value actually lowers the overall Helmholtz free energy, making that state more favorable. The temperature acts like a scale or weight, so at higher temperatures, increases in entropy have a bigger impact on lowering free energy. Think of it like how heat makes things more chaotic and how that chaos can help a process happen more easily. When entropy goes up, the system tends to favor that change because it reduces the free energy. This is why some processes happen spontaneously even if they requiring energy input, because the increase in disorder, scaled by temperature, outweighs the energy needed. At equilibrium, the Helmholtz free energy reaches its lowest point, meaning no more spontaneous changes occur. If a process increases entropy enough, it can actually decrease the free energy, pushing the system toward that equilibrium. So, minus T delta S captures the idea that systems naturally tend to move toward more disordered states, especially at higher temperatures. This term shows how disorder can drive changes, making processes more likely to happen on their own. It explains why certain reactions or physical changes happen spontaneously even if they seem to need energy. They're driven by the increase in entropy, which lowers the free energy. In simple terms, minus T delta S is about how the system's desire for more disorder, especially when it's hot, helps it find the most stable, lowest energy state. This helps us understand why some things happen naturally and how energy and disorder work together to shape the behavior of physical systems.